Hi, can you hear me now?
Yes.
Let's talk about our agenda for today's workshop.
Sure.
So, yeah. Wait a second.
Sure. No worries about the noise. It's okay on my side.
Okay.
Yeah, so for the agenda, Mr.Orest will be here hopefully within 5 minutes, and you can just introduce him and let him speak, let him start the talk, his talk directly. And after that,
Okay.
I can be talking about the after his speech ended, I'll be talking about the following format, which is the breakout room format, and kind of tell everyone, hey, it is now very good time to have a face-to-face session with floor members and floor engineers and have a present chat with them. And we can just show them the links, the breakout room links, four of them in the chat room, and we'll be bringing them into different rooms. And I'll be saying that, hey, after the session ended, please go back to the main room as the school instructor, when the school instructor tells you to do so. And in the end of the session, which will be no later than the whole session will not be longer than 2 hours. And after that, I will be saying, hey, thank you for today, and please register your wallet address in this day. You have homework like this, and see you tomorrow, things like that, and close the workshop for today.
Okay, sure. All right. Wait a second. Let me see. All right, so today we have Orest, Jerry, Zhang. Sorry, excuse my pronunciation. Rochu in Ditang, is that right?
Correct. And me and Zhenqi will be in the same room. So
Okay, Zhang. All right.
who is calling me? I don't know why. So hey,
Yeah.
hey, Queen, what's going on? I'm in the workshop room now. I'm in the workshop room now. What's the matter? Huh? Maybe it's just issues from where no worries. Type to her. Okay, it's just confusion. We resolved that. So anything else from you? Hmm?
Em ơi, nãy Cherry đang gọi cho các speaker hả?
Hình như thế ạ. Tiên gọi à?
Okay, so you can hear me again?
Yeah, sure.
Okay, cool.
All right. So, yeah, do you have like the limitation of participants for each breakout room?
Maximum, you mean maximum number of people, correct?
Yeah.
No, we just make it because we cannot distribute that evenly, so we just make it random. Like if we have 50 people and 4 rooms, and it can be anywhere between 3 people to 30 or 40 people, I suppose. Let's just make it random.
Yeah. So I will remind them that each room will be distributed like quite equally. And can you please talk to them about like the topic of each breakout room so that they can choose on their own?
There is no specific topic because our idea is to be let people in Vietnam to have a chance to chat with the best a little shy to say that best people, best engineering people in the world. So there is no topic they can ask whatever they want from Scroll itself, from hackathon, from even employment, things like that. Yeah.
Okay, cool. All right, so I guess we are ready.
Yeah, so I'll ping to see if our speaker is there.
Okay. Once the speakers are in, please heads up so that I can get you guys as the co-host of the stream.
Yeah, sure. Okay, I'm pinning them. Okay, so I've made Luo as co-host, and Orest should be here soon. And then Yi-Chen is never mind, I'll raise them as co-host. Oh, Orest is here.
Okay, shall we start? All right. Okay. Hi, everyone. Welcome to our workshop number 2 of the ETHEREUM virtual workshop event. All right. So may I introduce myself? I am Hazel, the moderator of today's workshop. Currently, we have Mr. Jerry Ho from Scroll, Mr. Jianji, and our main speaker today, Mr. Orest, is having a little bit connection problem issue. So yeah, we will wait for him for a while. He introduced a little bit about ETHEREUM 2022 and the Build-a-thon. All right, so ETHEREUM is the first and biggest hub for the blockchain community to build and learn together. The event will be hosted in Ho Chi Minh City from the 25th to the 27th of November 2022. So if you haven't registered yet, let me show you how to. Okay. Okay, so this is our event. If you haven't registered to join the event yet, please scan this QR code and join our Discord server to have a hand. All right. Okay. And before that, let's talk about our Build-a-thon. Our Build-a-thon is a hackathon competition for everyone to join and try to learn to build together. With the main topic is Web3 application. The Build-a-thon has the total of rewards to up to 60,000 USD. So please join because we have so much fun and so much rewards as well as so much knowledge for you to get to earn. Okay. The event will have the participation of a lot of big names in the blockchain industry. For example, Scroll, as we are attending the workshop today. All right. Yeah, so let's back to our workshop today. We are having Mr. Orest, the crypto infrastructure Scroll, to be the main speaker of today. And let me guide you through the agenda of today's workshop. We're gonna have like the main hall. This is the main hall. Okay. This is the main hall of our workshop today. We're gonna learn about the main topic, and after that, we will you guys will be separated. You guys will be put into small breakout rooms for smaller activities and more details, so that you can have the chance to directly contact and talk to our speakers from Scroll. Okay. Yeah. Okay. Is Mr.Orest already in the workshop right now?
It seems that there is some connection issue at the moment, but no worries. Let me introduce you about Scroll for the moment. He's trying to join our meeting room. So, okay, so for you guys to know, layer 2 is a general term for scalability applications. And for now, before we have some techniques like you may heard of that, like state channel, like plasma, and recently we have roll-ups or even zkEVM roll-ups. And until now, the ultimate solution to the whole layer 2 stack, it is called zkEVM. And in today's presentation by Mr. Orest, he will be introducing you about the whole stack of the core infrastructure, the history of layer 2, and he'll trying to let you know the details in Scroll's infrastructure, so that people will know why should I choose Scroll as my layer 2 infrastructure instead of other scalability solutions, and how is the tech stack inspired? What took us so long until for in the DeFi summer in 2018 until now that we finally have a very flexible solution that we can use as scalability solution. And so let me see. Wait. Okay, so back to you. I'll see how Mr. Orest doing.
Right. So, while waiting for the Scroll team, can you please raise your hand if you can join the ETHEREUM event in Ho Chi Minh City this November? Please raise your hand. Otherwise, you can always send us questions about the connection and how to join the breakout room, as well as any questions related to this workshop in the chat box. You can ask me. You can ask everyone, or you can chat to me privately. Okay. The other way is that you can always raise your hand if you need help. All right. Okay, I can see a hand from a participant named Gun. Okay, see you at the ETHEREUM event. All right. Okay. Yeah, you can start giving us the questions from now on. We are always open to that. And after this introduction part, we will have like the breakout room session, and we will put the links to each breakout room in the chat box later, so that you can join, and we will have a spotter in each breakout room for you to ask for. So no worries. Yeah, I can see that Mr. Yi Chang from Scroll is now in the workshop.
Hi.
Hi, yeah.
Nice to meet you.
Can you please start your video and maybe communicate with us a bit?
Okay. Wait a minute. Hi guys, nice to meet you.
Nice to meet you, Yichen. Can you please introduce a little bit about yourself for every participant in our workshop today?
Yeah. Wait a minute.
Okay. All right.
I think my computer has some problem. Just give me 1 minute. Yeah. Sorry.
All right. Okay.
Okay.
So while waiting, let me go back to the ETHEREUM event for a while. Okay, I'll give you a QR code to join our Discord server. All right, wait a second. So that you can get any information that you need to join the ETHEREUM or the Build-a-thon 2022. Okay.
Okay, I'm fine right now. Should I introduce the scroll reward? I don't know. I just a little bit late for this meeting, so I don't know what is previous process is. Should I just introduce the scroll reward?
Okay, please go ahead.
Okay. First, I want to thanks to ETHEREUM and Tarasiuk for hosting this event. I think Vienna is an amazing place now. I really want looking forward to seeing you all there. I will be there, right? And Scroll is building a event equivalent zk rollup solution layer to chain right now. And to scale Ethereum, we are building a practical level compatible zkEVM so that developers and the users can get exact same experience on Scroll as layer one. We are open source project since day one, and we are working with Ethereum Foundation to build this zkEVM. And eventually, this zkEVM will also be used for layer one scaling. So through Scroll Reward, we aim to help the Scroll community become more diverse and prosperous. We're supporting more decentralized contributors to build their own project. And we welcome all open source projects, groundbreaking research, and all public good and educational projects to help that helps developers and researchers. We will set up 3 rewards for this: gold, silver, and bronze. And there may be multiple gold or silver or bronze awards. At the same time, it all depends on the project itself. So let's go ahead and build whatever you want. Enjoy the hackathon. The gold reward is $3,000, and silver award is $2,000, and the bronze award is $1,000. We will also set up a prize pool of $2,000 to reward other participating teams. In addition to financial support, the winning team will be eligible to join Scroll mentorship program. Members from the Scroll RD team will support the winning team for 1 month. Each winning team will be assigned a mentor, and during this process, the team will provide support wherever the team needs help, such as technical support, project collaboration and introduction, and technical or community feedback, etc., etc. So after the end of 1 month, if you need our ecosystem grant or to continue to complete your next milestone, we'll also evaluate according to the project follow-up in the past 1 month. So submission criteria for Scroll reward is you have to deploy on Scroll testnet and or Ethereum layer one. I think it's the same because any Ethereum layer one contract can be migrated seamlessly to Scroll because Scroll is an event equivalent, right? So we welcome all builders to develop and experience the Scroll testnet. And we welcome or innovative applications, open source developer tools, developers and researchers education, onboarding projects, and even Ethereum research improvements such as EIP, etc. So I think that is all about Scroll reward. Just come and build.
Okay, thank you, Yu-Cheng. All right. So according to our participant list, there are some newbie builders and also some students. Do you have any advice for them to join the Scroll Prom?
Yeah, I think I think we support all background people, no matter you are a student or anyone. Yeah, I think it's pretty same. So if you have any questions, our mentor or team members will be there, support you all here. So just build whatever you want. Yeah, don't think about too much. Yeah, enjoy.
Okay, that is very good advice. So yeah, please join Build-a-thon, people. And hi, Oresta.
Hi, can you now see and hear me?
Yeah, I can see and hear you now.
Oh yeah.
welcome on board. Okay,
Finally.
so Orest, because you are the main speaker of today's workshop, can you please introduce a little bit about yourself to all the participants here?
Yeah, totally. So sorry about my tech issues. My name is Orest. I have been with Scroll for a bit over half a year now. I joined early this year. My background is in computer science. I spent the last couple of years, the last 6 years or 7 in tech startups outside of the crypto sphere. Crypto has been like a side hobby for me during that time. And so I'm super excited to talk a bit about how to get up to speed in terms of deep diving into crypto.
Okay, thank you. Can all of us meet you at the ETHEREUM 2022 in Ho Chi Minh City this November? Sorry, could you repeat? Okay, can all of us meet you at the ETHEREUM 2022 in Ho Chi Minh City this November?
Unfortunately, not in real life. This time, just a few team members are present physically. I'll be joining remotely only this time.
Yeah, but no worries. All of the other people you see on screen, like Roju, Yi-Chen, or Jerry Hall, we all will be there with you guys among your hackathon journey. And we are really looking forward to see you have a very amazing ideas about Scroll or about the whole Ethereum ecosystem. Yeah, so expected to see you all there.
Okay, so everyone, please join, register now. Don't wait. Okay, thank you guys. And yeah, shall I present the way to join the breakout room now?
So we just stay in the big room at the moment, and please, Orest, to start our brief introduction for the whole layer 2 today. And after that, we'll make everyone to join in small rooms, and we can talk about if you have any questions and interact there later. So please welcome Mr.Orest.
Yeah, I think we can skip the Mr. Please just call me Orest. That's, I think, a bit easier for me as well. I was thinking we could make this session kind of interactive. I think that participants, they don't have an option to raise hand or talk on video, right? They can only chat. Is that correct?
Yeah, they can chat and they can raise their hand. So if you have any questions, please carry them to raise.
And raising hand means sending a hand emoji in the chat, or is there another function for that?
It is a function of QuickCom. They can raise hands, like there is an icon on the screen.
Okay, cool. Yeah, so the way I would suggest we go about this is for you guys, and welcome all 47 participants in this Beowulf chat. And I guess there's some on YouTube maybe. Feel free to raise a hand anytime and also ask questions in the chat directly. And we have a couple of team members from Scroll on this call and myself, and we would love to be kind of use the time that we have to be kind of individual and be able to approach you in this high custom way, so that we can talk about what interests you, so that it speaks to you best. Okay, so I see we have a couple of questions already. I would suggest maybe Jerry, would you be able to moderate the questions? Like find the correct time to talk about them? Would that be possible, Jerry?
Yeah, absolutely. I will collect the questions and let people answer them in our breakout section.
Yeah, that we can do, but we can also answer them during the talk. So I will be putting in, I will be just asking you, Jerry, what questions you think we can discuss as I go. Okay?
Okay, cool. I'll let you know in our DM. Cool.
All right, cool. So I titled the talk "Scaling Ethereum with Rollups and Zero Knowledge Proofs." And the idea here was, hey, like this many keywords that sound and look kind of scary. Now, how many people can define scaling, an Ethereum, and a rollup, and a zero knowledge proof? Probably not that many. It's buzzwords we've been hearing for the last couple of months, maybe years. But few people actually know what these are to mean. And this is a realization I came to have only recently. At first I thought, hey, Orest, it's just you. You are a newcomer to the space. So you should know all of this. Everyone knows these terms. Everyone knows the math behind all of this. And you need to catch up. And it's only been in the last couple of months that I realized, hey, this is normal. These things are new. Things are moving very fast in the crypto space. Things are moving even faster in Ethereum scaling. So I think it's important to not be scared away by all of those keywords and instead work on education instead. And so it used to sound scary to me, and that is in a context that's a bit broader. Now, I will give you the brief outlook of what we are going to discuss today in the next, say, 20 minutes. And so I will guide you through how you might enter the world of crypto, and I'll give you my example. I will present briefly the so-called blockchain trilemma and Ethereum's choices with respect to that trilemma. We will then talk about how to solve the third item in the trilemma, which is scalability. And we will be doing this zoom-in approach. So we will be going level of abstraction by level of abstraction, deeper and deeper into finally talking about the zkEVM, Zero Knowledge Ethereum Virtual Machine, which is the approach that Scroll decided to take. And finally, we'll hear very briefly about where Scroll's at right now on that in that context. And so first, I'd like to start with a personal story of how my touchpoints with crypto unfolded. And that was, I think, quite uncanonical, uncommon, a direction to come from, which is mHealth, mobile health. The back story to this is I founded a startup with a friend, and at some point we both grew tired, and we both decided to leave. And he left for Ethereum Foundation. I left to found something else. But he's ever since was it that he's been telling me those stories about secure multi-party computation and being able to contribute to a shared secret without revealing any of it publicly or to other people that you don't trust. And I've been taking it with a bit of a grain of salt, thinking, hey, yeah, you know, this is something of a curiosity in theoretical research, and this guy is a theoretical academic, so he finds it cool, but it's more of yeah, I guess something not very practical. And it was only, I guess, 2 years later that I realized these things are actually becoming a reality now. And it's actually when I guess, started reading, catching up on some most recent blog posts on Vitalik and ETH research, stuff like that, when I realized, hey, zero-knowledge proofs and secure multi-party computation applications, they are actually out there in the wild and they work. And it's super exciting to see this. And so I decided to join this space as well. And what this might mean to you, I guess many people in the audience are developers or have some sort of touch point with computer science or engineering, but might not have been in crypto professionally for a long time. And what this means is you don't need to. It's normal. The space is very early and it's moving very fast. And there's a lot of traditional computer science expertise to be reapplied, to be transferred to the problem domain of the blockchain. So yeah, don't be scared. Now, let us talk. Any questions at this point, maybe? Just to run the structure as we intended. I see no new questions in the chat. Jerry, do you have anything from other mediums? YouTube, Twitter, whatnot? I guess not.
Yeah, to be honest about your question, we don't know if it is possibly due to efficiency reasons, because personally for me, I'm in the engineering team and we have a mindset which is very greater than all, but we do not sacrifice on some basic ideas such as decentralization or open source, etc. So for the candidate instead of bulletproof, I personally cannot answer you in great detail. You are welcome to ask in the breakout session. Some of them, our scholars are of zkEVM team's members. But at the moment, I can only tell you that it's due to efficiency reasons. Yeah.
Also, along these lines, by the way, it's normal people ask about these, and we have a very active Discord. And so feel free to join our Discord and engage with the community there. It's actually super exciting to see how engaged other people in the community became. Okay, so let's talk Ethereum. Why are we even here? If you think about Ethereum, it looks like everybody loves it, especially in certain bubbles, except even Google knows, and it gives you as this top unfiltered suggestion in the highlight area that Ethereum, and you will see different numbers when it comes to the problems, but they all boil down to scalability. They all boil down to Ethereum supposedly not being able to cope with a lot of traffic. That's what we mean by scalability usually. And so, is this an Ethereum problem, or is it a blockchain problem? Or even more broadly, again, we want to abstract the blockchain bit away, maybe. Maybe it's a DB problem. In computer science, we get taught about the cap theorem, where you can only have 2 out of 3 desirable properties. And these kind of translate into the blockchain space as well, where they evolved into being called the blockchain trilemma, something from many decades ago, kind of refreshed and made to look like something very new. But it's not really that new, and it's not really something very surprising. It's not something very surprising if you have a look into the academic research at depth. Now, what is it exactly, this blockchain trilemma? Well, again, it's the problem where you have 3 desirable properties, but you only ever get to pick 2 out of the 3. And so in our case, in blockchain, the properties are security, decentralization, and scalability. Now, because Ethereum decided, and that was a conscious choice, a deliberate one, to sacrifice scalability in favor of keeping the security and decentralization property, that's where the 15 TPS, 15 transactions per second, come from. And so this isn't a random choice, and this is a deliberate one. And there have been alternatives to this choice. Now, Ethereum could have sacrificed something else. So for instance, we could have gotten rid of, I think I'm missing a slide here. We could have gotten rid of decentralization. Then we would have ended up with something like Visa, a centralized high throughput and secure system. We could have gotten rid of security, where we would have been kept with a decentralized and scalable system, but at the cost of being able to get hijacked more easily. Now, did Ethereum really sacrifice scalability? Many people have different theories here, but what you can see and look up for yourself is that solutions to scalability have been on Ethereum's roadmap for many years already. And one of the candidates back then, and probably the favorite for a good 2 years now, were the L2s. By L2s, we mean layer 2 solutions, as in opposition to layer 1 being the Ethereum so-called base layer. With the idea being, hey, let's apply again the very traditional non-blockchain specific rules and recommendations in computer science of modularizing. And let's have this module that provides a high level of security and a high level of scalability. And we call it the base layer, the L1, layer 1, the Ethereum layer. And then let's try to set up an additional layer which inherits those 2 properties while focusing on solving for another problem that we have. In this case, scalability. And so what happens if you again trust Uncle Google to give you a highlight so that you don't need to dig deep? Well, you will get one quick definition of the blockchain L2, revolving around being a network or technology operating on top of the protocol itself, the base protocol. And I also like the definition by L2Beat, which focuses a bit more of this inheritance aspect, wherein an L2 inherits those desirable properties from the L1 and gives certain guarantees to the user such that they don't need to rely on the honesty of the L2 validator, like the L2 active participant, node participant. Any questions to this point? I see there's quite some activity in the chat. And Jerry, could you moderate here?
Yeah, currently the people are just discussing a very deep part about our mathematical progresses about recursive proof and things like that. But there's some question regarding the main part that is the current thing you are talking about. So no worries.
Okay, cool. Oh yeah, very nice. And by the way, we will have a couple of more sessions that will focus on more in-depth dives into Scroll and proving later on during this conference. Okay, now what L2s are out there. One type of an L2 is a rollup, sometimes referred to as the end game by some people. Now, what types of rollups do we have out there? Let's just try to have maybe some sort of hierarchy structure to this wild world. We can speak about two broad categories of rollups. The first one being optimistic rollups, also referred to as ORU, optimistic rollup. And the way the characteristics of an optimistic rollup are that we basically assume that network participants are honest, and we give some sort of a time window after a critical transaction wherein any other network participant is able to prove them wrong, to prove that a fraudulent transaction was executed in such an optimistic rollup. And the cool thing about optimistic rollups is they're out there in production, they're working, and they have a high adoption already. And the drawback is that because of this time window that we need in order to give time for people to check whether a fraud was committed, we have what we call slow finality, so that we need quite a lot of time. This is usually around a week prior to being certain that the transaction can be seen as final. And so that's very bad for certain use cases where the UX requires a high or fast finality. The alternative rollup category is those called zk rollups, because they are based on zk proofs, zero knowledge proofs. Now, a zero knowledge proof is a mathematical construct that's been around again for decades, but which has come to attention recently in the last couple of years, that allows the user to create a proof of the fact that certain transactions, certain steps were carried out according to some rules, such that that proof can be verified sublinearly cheaper, faster than rerunning the transactions that are getting proved. And so that's a very interesting property, right? You don't need to rerun the whole thing as in the traditional approaches to convince yourself that even though you don't trust the prover, the person giving you some sort of outcome, that the outcome is correct, that the outcome does adhere to the rules. And so zk rollups, they have fast finality, because once a user, a participant on the network sees the proof with the corresponding data, they can very quickly verify it to be correct, and so they can be certain that the transactions are final. And the drawback is the adoption of zk rollups is still low. This is a very early stage. So what zk rollups do we have out there? Well, again here, let's talk about the structure first. We had this property of being able to replace re-execution of transactions with this new mathematical construction that makes it easy and fast to verify that those transactions were correct. And also it has this nice property of being, usually it has this nice property of being succinct, which means it's small. So it doesn't require a lot of storage. And this gives us this property of not requiring trust with respect to the prover. So we can convince ourselves of the validity even though we don't trust the person who gave us the proof in the first place. And so this leaves us with the hierarchy within zk rollups for a change. This is one layer of abstraction deeper again. And now we have application-specific zk rollups, and we have general-purpose zk rollups. The latter we call zkEVM to refer to the zero-knowledge Ethereum virtual machine, as in the application-specific rollup, zk rollup, is only able to carry out certain certain subset of features of Ethereum. For instance, you can only send send ETH transactions, or you can only send a token or something like that. You can only do certain DeFi actions. And there's a couple of those out there that are quite advanced in terms of progress. And the general purpose zero knowledge rollup space, the most, I guess, trendy one recently, because it would allow people to run any code that the Ethereum virtual machine would be able to carry out, and prove that that code was executed as though it were executed in the EVM, and still have this benefit of being trustless with respect to the prover. So that's a very enticing property to have. So let's talk about the Ethereum virtual machine. We need, I guess, a general understanding of why we even talk about the zkEVM and not just say general purpose zk. You might be familiar from your non-blockchain education that virtual machines are quite a common concept in computer science, and serve to create some sort of a model in which you have a predefined environment that can execute code. And this environment can be physically run on any device or on several types of devices, and thus the virtual bits. So it's a virtual representation of a hardware device. And the way a virtual machine works, and that is similar to the Ethereum virtual machine approach, is that we have a couple of layers of abstraction that get translated or transpiled or compiled into one another. And so we start with some sort of a human-readable language, hopefully a human-readable one, such as Solidity in the case of the EVM, or Viper, that gets transformed into what we call the intermediate representation. And that IR, intermediate representation, we compile into what we call the bytecode, which is one level of abstraction deeper. And that bytecode contains the actual instructions that are carried out within the EVM. And the EVM itself has a couple of components, the most important ones of which are the state machine, whose state we change with those opcodes from the EVM bytecode. It has both stack and memory for random access, and it also connects to storage. Now, why we talk about this is that there's many types of EVM compatibility that we could have, that we could strive for. And you need to have a basic idea of the EVM to understand where the different types tie in, or at which point in this hierarchy that we've just seen, we actually exchange a component and put in this zero knowledge proof component instead. And so Vitalik has recently tried to come up with some sort of structure or hierarchy or naming for those types, and they extend from type 1 to type 4. and at this moment they are still getting discussed quite vividly. So this might change, and it changes quite fast. What is, I think, interesting to note here is that we could have a type 4 zkEVM, which basically has the fastest performance, and it's also usually the easiest to implement technically or engineering wise, but the least compatibility with the Ethereum itself. And then we can go up as high as to type 1, where we basically have Ethereum itself with zk proofs added. Now, why do we even bother for a zkEVM? Let's remind ourselves why we go this effort and this extra mile. Like we have this, there's so many other approaches, right? Well, one big benefit of striving for some level of compatibility or equivalence is that we get to reuse the existing infrastructure that Ethereum has been amassing for the last 9 years or 8 years. And that includes smart contracts that are out there. It includes wallets, but it also includes developer tooling such as IDEs and debuggers and block explorers and anything that's actually necessary for an ecosystem to thrive. The other thing is, with a zkEVM, we get to encapsulate this complexity of those mathematical proofs, mathematical constructions, very highly, so that the end developer doesn't need to know about snarks, or doesn't need to know about prime fields, stuff like that. They just develop the way that they've always been developing, with the benefit of knowing that the transaction costs are going to be way lower for the user. So it's in a way a very boring value proposition to the developer. Hey guys, nothing changes for you. You get to use your regular approach. And then we have the inheritance benefit of reusing the security of the EVM execution model that's been around for a long time and that's trusted highly. So how is this possible? Why didn't we do this before? What changed? I've been annoying you, I guess, with those references to the old times, decades ago, here, decades ago, there, not blockchain specific this, not blockchain specific that. And as usual, it's a combination of a couple of developments. So first of all, in fact, this is a niche specific thing. We do have better zero-knowledge proof systems. We have optimizations in code, and we have speed-ups in theoretical approaches to creating those proofs. Second, we have big gains in hardware acceleration for provers. So we now know that we can get huge acceleration if we reuse GPUs, for instance. And third, we have this amazing community out there now with a lot of bright minds, all trying to figure out how to make zkEVMs possible and practical. And at the very forefront, I guess we can mention the Ethereum Foundation, which has been working on this very hard for quite some time. And there's been a big ecosystem movement towards more and more attention, I guess, of very bright minds, resulting in more and more breakthroughs in the open source circuit engineering. And so how does a zkEVM look? This is kind of a simplified view wherein we start with getting what we call the execution trace. The way we do it at Scroll, for instance, is we just enable execution trace outputs in a geth. We feed these into a circuit builder that transfers these into a couple of several circuits. We split this up kind of logically so that we have a separate circuit for the EVM itself, as we've seen in the diagram earlier. We have a separate circuit for the RAM, the random access memory. We have a storage circuit and some more. And then we create a proof for those and aggregate them in an aggregation circuit to produce the block proof that is then used to show to others. How this works in the broader ecosystem, how the interoperability with Ethereum looks is that you can envision the connection as in there's this separate parallel blockchain network run with Scroll's modified geth, where people that we call rollers, so nodes, participants with bigger hardware, create those proofs, and they don't need to be trusted. And then some entity that we now call currently a temporary thing, I guess a Scroll node, gets to sequence those proofs and coordinates which blocks transactions proofs get put back on the L1. And at this point, we try to detect whether maybe a proof is not valid, is not complete, whether there's something missing or some fraud was committed. But that's a parallel thing. And now what interests most users is what happens on the L1, on the blue Ethereum layer that you see on the top of this screen. And that is, there's a separate contract on the L1 that verifies the proofs that were submitted by that Scroll node of ours. And it's only once that contract has verified, hey, I don't trust any of those guys, but I convinced myself that what they claim is valid, only then do we have what we call finality. Only then do we see the transactions contained therein as final and confirmed sufficiently. And the cool thing about this is it's way, way faster than what we've seen so far. And so you actually get to rely on this fast finality. So what about Scroll? Where does Scroll fit in this picture? Well, our vision has 3 components. Component number 1 is in fact what we used to call the native EVM equivalence. I guess now we would call it the type 2.5 according to Vitalik August 2022 post classification EVM equivalence. And by that we mean that the developer gets to reuse even his or her debugger because we are compatible with Ethereum on the bytecode level. And so this entire critical mass that Ethereum has achieved can be pretty much fully transferred and reused on the L2. Point number 2, decentralization. That's something that we care a lot about, and we care about it. We've been caring about it from the get-go. We have very active research in fields where the community is still not very convinced how to decentralize certain items in this broad roll-up-centric roadmap, such as the sequencer. And we already have a decentralized proving network architecture so that people can easily spin up their own machine and start creating proofs. And third, alignment with Ethereum and the Ethereum Foundation and the community, which also means that we've been open source since day one, and we co-build a lot of our components with the EF and broader community out there in the open. So now, where's the catch? It all seems so simple, right? Well, there's two catches. Catch number one, it's a direct catch. The computational cost to creating proofs is large. So that is a barrier to entry. That is something that prevents a naive implementation from being fast for practical appliances. And the other catch is on a meta level, the complexity of building the provers, the circuits, and designing the maths behind this and transferring it into engineering that actually works as expected. That is very time consuming. These are complex and kind of cutting edge things that we are dealing with here, where time is just the bottleneck. We just need people to work on these for quite some time before we can be sure that things work as expected. So where are we with Scroll right now? Well, we've just, I think 2 weeks ago or 3 weeks ago in Bogota, been able to open our pre-alpha testnet to external developers to deploy on. And so now I think ETHEREUM is the second hackathon, the second conference that will be able to interact with Scroll's testnet on this very intense level of being able to deploy contracts and interact with the network, pretty much as though it was live. And the next big step for us will be outsourcing the L2 proof creation, running on Gurley. And after that, we will be, of course, targeting a mainnet launch. So how can you sign up and learn more about the testnet? Well, just go to signup.scroll.io and you will be able to see the developer portal that you see here on the screen, go through the entire user journey and see for yourself what it feels like, how it looks to transfer funds between the layers and play around with smart contract deployments as well if you are a developer at the hackathon. So that is the brief summary of scaling Ethereum with rollups and a very brief excursion into zk rollups and the zkEVM and what Scroll does. We will have more talks that will be more focused on Scroll's architecture specifically, and we will also have several people from the team, including engineers, support throughout the hackathon. So I think, Jerry, I will hand over to you now and ask you for questions. I see the chat has been very active, which is super cool. And we also still have all participants in here, which is very surprising and very flattering.
Yeah, it's so good to see so many Vietnamese or people from all around the globe to be interested in our testnet. And thank you all to repay to you guys. We have please wave to everyone. Luozhu, Luozhu. We have Orest, we have me, Jerry, and we have Yichen, YCHENG. We will then separate people into 4 different rooms, and we can interact with you closely there. And please don't be shy and open your mind and speak to us so that you get to know more about you and you get to ask more questions from us, and we can have a pleasant interaction time. So yeah, almost forget it. For that,
do we have
we have questions. Yeah. Of course. So Chair asked 2 questions. The first is how many precompiles have we implemented for now? Like for some of the upcodes, we have skipped that at the moment, but for some of the upcodes like self-destruct, it will be obsolete on Ethereum mainnet soon. We won't be doing that also. But do you have a current update on precompiles available for now? Do you have a list already?
I think we might have a list online, and I think it might be guide.scroll.io. And otherwise, if you could go on our Discord as well, things are moving quite fast. So the Discord is always the most up-to-date place to get info from.
Yeah, we'll be happy to answer you there. And for another question, how strong the hardware should be to run the scroll nodes and the proof node? And on that question, we'll say that our work is still a work in progress, so we'll be improving that soon. But for the info we can provide, please correct me if I'm wrong. For the info I can provide to you is that we are using RTS 3080s at the moment in our proof node, and we plan to make it affordable or efficient for average home users to run your proof node. Not just those people who can afford ASICs or FPGAs. So yeah, but currently we don't have a timeline yet as to when you can start to run your proof node. But for regular 4 nodes on L2, the instructions of it will be released pretty soon, so that you can run your own 4 node archival nodes and to better run your secure data, retrieve your data on our layer 2 efficiently.
And so maybe to expand on this, that instance on Amazon, it has several GPUs and it has a few hundred gigs of RAM. It sounds like a lot, I know, but this is pre-optimization, first of all. Second of all, it costs approximately like 2K per month to be running such an instance. So not trivial costs. It's not a Raspberry Pi, but it's not like you need to be a big company or a big bank to be able to participate already, even pre-optimization.
Yeah, there's one thing most very exciting, or I would say for me, I'm just a regular engineering team member, but once I've heard from our Proof team's member that just by multiplying about 10 lines of code and our Proof running time reduced by about 33%. And that you think about it, that is a significant amount of reduce just by modifying less than 10 lines of code. So yeah, there's a lot of headrooms to be improved engineering-wise and theory-wise. And yeah, we are striving to make our initial target feasible. That is to make the whole layer 2 truly decentralized and to be runnable by everyone.
Yeah. Okay. If there's no more questions, shall we split up into the breakout rooms?
Yeah, so the moderators, please. Yeah, I saw the links there. And yeah, please, for participants, please join each room as you like it, and we will be there to answer your questions. And for one last question get asked by Chair, he said that any plans to support account abstraction on Scroll? Yeah, that's a good question. Basically, you can take Scroll Layer 2 as sort of a trial, sort of a test version of Scroll mainnet. As you already know, Scroll mainnet, Ethereum mainnet is kind of progressing slow due to community reasons, due to its inertia. But on Scroll, we can test and plan on supporting many EIPs in advance of the mainnet. So that is to answer your question directly. Yes, we are very eager to support account abstraction in ahead of Ethereum mainnet, and we will see how it goes, because it will be a very good indication to the mainnet as to, hey, account abstraction is good and we implement that. So please mainnet, go ahead and implement that too. Yeah.
Cool. Also, if you guys have any questions later on, feel free to hit me up at RSTA. on social media, and hit us up on Discord as well, which you can find at Scroll.io and the Discord icon. All right, so we are moving to breakout rooms now.
Yeah, so Hazel, please.
Okay, all right. Can you hear me?
Cool.
Okay,
Yes.
all right. Thank you so much, Orest and Mr. Jerry, for answering and help operating this workshop for everyone. Now is the breakout room session. As I have mentioned in the chat box, for our breakout room session, please get out of this main hall and join in one of the specific links that I pasted in the chat. There will be Jerry, Janji, Orest, Rojo, and DJ and Chris to support you guys. You can always ask for questions and raise your hands if you want to discuss with our speakers. And after the breakout room, everybody please go back to the main hall to this current link for wrap-ups.
How long is the session? When should we go back?
We will have our supporters, our moderators in each breakout room to remind everyone. It will take about 30 to 40 minutes.
Cool. Thanks so much.
Okay. Thank you, guys. Everyone, let's go.
All right.
Yeah, see you in the breakout rooms.
See y'all.
Hi.
Okay, I have reminded people to go back to the main room, and I think I will need some time to show people and to remind people again about the Discord server of ETHEREUM and also the channel of Scroll. So yeah, I will spend like the first few minutes to talk about that. All right. Do you have any market support for the project launching Build-a-thon? Can you hear me?
Oh yeah, I can hear you now. Sorry.
Okay. So I was about to ask you for a little bit, for a few minutes to talk, to remind again about our Discord server.
About what? Sorry.
About the Discord server.
Oh yeah, cool.
And the
Of
Scroll
course.
channel as well. I will show the QR code scanning, and yeah, that will take about like 3 minutes, I think. That will take about 3 minutes, all right? And then we can wrap up and do we have like the homework for the next?
Yeah, of course we do. So please, would you like to you mean you introduce the Discord server by you or by me or?
I will introduce the Discord server and then I will pass the mic to you so that you can talk about the homework.
Cool.
Yeah. And I will also talk about the next workshop and tell people to stay tuned and join us tomorrow.
Cool.
Okay, all right. That's cool.
Sure. So in the meantime, how are you guys doing in the breakout section? Did you stay? I mean, as Asia people, we are often really shy and we are so afraid of asking questions because there are so many others. I'm really hoping that by putting yourself in a smaller room, you are more like really brave enough to ask questions. But if you did not ask your question or you are feeling like, hey, you still need something more, please now open your mic and ask me some questions so we can have some friendly discussion if you want. Now is a chance, please. Anyone?
Okay. It seems like a lot of people are shy today. Yeah, but actually, I am very glad. I think both I and Jerry are very glad to have like Chair in our room as a very passionate and active Build-a-thon participant, right?
Yes, correct.
Yeah. How do you feel about after the sharing of Chair and like other participants?
Yeah, I mean, it is so. And before this, I thought it will be only local Vietnamese people here. So I was like, hey, so maybe I should be focusing on discovering the things, the goods, and the beautiful scenery and the foods in Vietnam. And I spent like half the afternoon and last weekend for it because it is so important for me to know the people in Vietnam, to know each other because we want to be collaborating with Vietnamese local developers in the long term. Later today, just today, I found out that hey, people like Che he's from Malaysia and he's very passionate about the zkEVM applications that he's going to build, and he told me about his local community, local meetups, and all the things they've done, and they are pretty significant and pretty. I mean, I would say good job like 1,000 times. And I think for the people in the same room with Che, hey, you are so very unfortunate because you can, in a sense, copycat his way of doing community and have your own community and to be honest to gain from it, whether it's money or connections or what. But we are in this build-a-thon in this builder community, so we all have an engineering heart, and it is all by collaboration and sharing that can make our way more smooth and run and in the long term, and we all can feel happy and benefit from it. So yeah, that's what I have today. I hope that each of you in the other breakout rooms today have shared the same experiences, and that experience will be continuing tomorrow and this Thursday. So yeah.
Yeah. Please stay tuned to our next two workshops on tomorrow and on Wednesday, right? Yeah, and as Jerry has said, let's build together, let's grow together, especially when most of us are from Asia. All right. So how you can share? Please, I will show you the QR code to our Discord server so that everybody can communicate, share with each other, and talk and ask teachers, trainers from Scroll in Scroll channel. All right. Let me share the screen. All right. Can you see my screen now? Yeah.
Yes,
So this is
clearly.
okay. Thank you, Jerry. So this is a QR code to our Discord server. Because the NFT link is in maintenance right now. So yeah, please join our Discord server, join Scroll server, and text chat in our Discord ETHEREUM Discord server to your ENS wallet address, so that we can send you our NFT as a gift for you guys to support ETHEREUM 2022. All right, I will give you guys about like 2 to 3 minutes to scan, right? Okay, so meanwhile, let's talk a bit about our next 2 workshops. We have another workshop, the workshop number 2 tomorrow, and workshop number 3 on Wednesday. Both of them are hosted by Peter, right?
Yes, correct.
Yeah. And it's not a very typical workshop when people like join and go and join and go. Surprisingly, we have homework for you guys, right, Jerry?
Yeah, of course. So yeah, for today, I don't know what's the complete situation in other breakout rooms, but in the first part, always kindly walk us through the layer 2, through the zkEVM from the greatest aspect to the smallest landscape. But of course, it is pretty highly complicated, and in some of the part, I mean, some of us are engineers, we have to know some of the details, the keywords in that, in order to build apps in that. So for the workshop in tomorrow, everyone, please, if you have time, please click the link in the chat and fill in your Ethereum address and your name so that you get to enter our Scroll testnet earlier as a developer, so that you can have your testnet faucet, have your testnet money, and to deploy your contract in tomorrow and in Thursday. So yeah, basically in tomorrow Hazel, please, there is a request in chat. And so in tomorrow we'll be dive deeper in specifically in Scroll's infrastructure. We'll walk to like Che just asked earlier today about hey, what kind of pre-compiled apples are we supporting? I mean, compared to some of our, I would not say competitors, but our friends, they do not support some of the pre-compiles due to efficiency reasons and due to the test stats that the hashing algorithm they use. But there is a word called Ethereum compatibility, so we try to support them all. And currently, Scroll testnet will show you tomorrow on some of the questions about hey, what kind of contract can be migrated onto the Scroll testnet to directly, and some of them can be migrated onto Scroll testnet just by a little bit of modification, etc., etc. That'll be the third day. That'll be the third day, and tomorrow we'll be deep dive into our infrastructure, and another breakout session after that, so you can ask more detailed questions about our infrastructure, be it how is your proof of network, and how is your L2 gas work, and things like that. And please make sure to fill in the Google Doc link in the chat session, so you get to access our testnet for today and tomorrow. Yeah, thank you all for participating today, and thanks Orest and thanks Hazel for all of your efforts today.
Yeah, thank you, Orest. Thank you, Jerry. Thank you, Loto, and thank you, Yi Cheng, and all other participants for joining us today. Remember to join us tomorrow at 4 p.m. 4 p.m. right? To learn more about Scroll and our event. All right. Okay, thank you. And yeah, please join our Discord for more discussion. Enjoy Jerry's Google form. Yeah. Okay. Thank you, guys.
All right. Thanks so much, everyone. It was a pleasure. See you.
Yeah. Goodbye.
See you tomorrow.
See you tomorrow.